Hello, everyone. Thanks for being with us today. Today, we have Dr. Wilma Bainbridge from the Bainbridge Lab at the University of Chicago. Wilma first spoke at our Extreme Imagination Conference in 2021 about the relationship between aphantasia and memory through drawing. Today, we'll be talking about her work on the theory of dual coding. And Wilma, thank you so much for joining us today.
Hello, thank you so much for having me.
Well, let's start maybe just with a little bit of background and introduction so everyone who's watching can get to know you a little better.
Sure, yeah. So my name is Wilma Bainbridge. I'm an associate professor of psychology at the University of Chicago. I've been here at U Chicago for about 6 years, and my lab's really interested in studying um, what do we remember and why. And aphantasia has actually been a perfect lens to look at like what do our memories actually look like? Because it seems that individuals with aphantasia might have memories that look fundamentally different from those without aphantasia.
Yeah, and it's one of those ones that is really interesting and important to people because it seems like without images, just at the surface, it would seem like maybe your memory would be worse or you can't, remember the kind of rich detail that might accompany a visual picture in your mind. And which is why, this work is so interesting. But maybe let's start like what maybe initially drew you to study people with aphantasia? Like, why are you doing this kind of work?
Yeah, well, actually, how it started was I was at this conference called the Vision Sciences Society as a new professor, and I had seen this grad student who was doing work on aphantasia, and I had been doing work on using drawings to look at what's in people's memories. And when we met each other, we were like, "Whoa, what you're doing is so cool!" Like, I was curious, what would aphantasic individuals draw from memory? And then she was also curious about using this really rich method to look at memories. So that's what got us started. But also, I mean, aphantasia is so fascinating because, as you mentioned, many people with aphantasia are totally fine in normal life. They might not even realize they have aphantasia until later in life. So, and they remember things just fine. So it's not like they are amnesic. Somehow they have these rich, vivid memories, but without necessarily the visual component.
Yeah, yeah. And so what, for listeners who might not know, can you briefly explain what dual coding theory is and why maybe it's influential in memory research?
Yeah, so there's this well-known effect called the picture superiority effect. The idea is that people tend to better remember images than words. So you might remember the picture of like a beautiful beach scene better than the word beach. And there's many theories as to why, but one of these key theories is called dual coding theory. So the idea here is that when you see a picture of a beach, you have the visual information, but you also have the name, like sort of the linguistic or semantic information. You have the word beach that pops in your head. And so the idea here is that people can use two ways to access that memory. If I want to think back on my beach vacation, I can access it through the visual route by remembering what it looked like, or I can use the language-based route of remembering the word beach. And the idea there is then that we have dual codes we can use to access that image. But if we just have the word beach, we don't necessarily have the visual code that we can use. We only have the word. So then we only have a single code. Yeah. So
So the
does that
theory
make
would be
sense?
that
Yeah,
aphantasics couldn't use dual coding because we don't have that visual pathway.
exactly. That's the hypothesis. Yeah. If dual coding were accurate, then indeed you would think that individuals with aphantasia would not have this picture superiority effect because they don't have that visual code.
Yeah. So let's talk a little bit about, kind of what the study was that you did and what you found.
Yeah, yeah. Another great thing about the study is that it both tells us a bit about aphantasia that I'll talk about later, but it also answers these fundamental questions about like how does memory work, right? Yeah, so the study itself was pretty straightforward. So people had to do a memory task and we recruited both aphantasics and controls. And so for the memory task, they had to see a series of pictures or a series of words. Then they did a totally unrelated task where they had to categorize tones like as high, low, or medium, like dee doo doo. And then we then tested them on their memory by asking them to write down everything they remember from before. So in practice, you would see a series of words like cat, robot, cake, have the tone task, and then write down robot, cake, cat in any order. But then in some blocks, you'd see pictures of a cat, a robot, and a cake, and then have to write down robot, cake, cat after. And then the key question is first, do we replicate the picture superiority effect? Like, do people do better at remembering the picture versions or the word versions? And then second, are there differences between people with and without aphantasia?
Interesting. And what did you find?
Yeah. So first, we did replicate the picture superiority effect. So typical, like people with typical imagery, remembered the pictures better than the words. But the surprising thing is we also replicated it in people with aphantasia. So people with aphantasia also remembered the pictures better than the words.
Yeah. So, I mean, that's a key finding.
Hmm.
Why? I mean, what do you think is happening there? Why do people who don't visualize actually remember pictures better than words?
Yeah, maybe I'll also describe one more finding if
Okay.
that's helpful. Yeah, so we did look at the classic picture superiority effect, but my postdoc Brady Roberts, who was really instrumental in mentoring for this project, he also has discovered something called the symbol superiority effect, where people better remember symbols like dollar sign, at sign, ampersand better than the words that they're associated with. You'll remember the dollar sign better than the word dollar. So you can think of that as a symbol superiority effect. And what we found in our study was that also people with and without aphantasia also showed this symbol superiority effect.
Okay. Oh, okay. Interesting.
But the one difference we did find between people with and without aphantasia is that individuals with aphantasia did much better on symbols than they did on pictures. So they still showed this evidence against dual coding, but they remembered symbols better than pictures. And so that will lead to some of the interpretations I'll talk about.
Yeah. So just to recap, then, if we show a photo of money, dollars, or we show a symbol of dollars, the dollar sign itself, for some reason, is remembered at a higher level, and that is true for aphantasics and visualizers.
Correct. Yeah.
But there was a difference between the visualizers and the non-visualizers. And can you explain that difference again?
Yeah, so for visualizers, they remembered the picture of dollars, the dollar sign about equally well, and remembered those better than just the word dollar, DOLLAR. But for non visualizers, they remembered the dollar sign the best. Then, second best was a picture of like money. And then, third or like worst would be the word dollar. Yeah.
Yeah. So why do you think that is? Why do you think that there's a difference in aphantasics between the symbol and the image?
Yeah, and so this gets back to your question of why would non-visualizers have the picture superiority effect? Okay, so I'll walk through this step by step. Maybe stop me if you want to pause or like
Sure, sure,
reinterpret
sure.
anything. Okay, so first thing is that these results show us that dual coding theory cannot stand as it is because individuals without that visual trace are still showing the picture superiority effect. Yeah. So that means that basically, thanks to individuals with aphantasia, we've sort of disproven this really long standing psychological theory. Yeah.
And it's
When
been
is it from?
like 50 years or something,
He's
right?
like 50 years old.
Yeah,
Yeah.
yeah.
So it cannot be that we are using both a visual and a verbal route because people with aphantasia don't have the visual route. Okay, so that means we have to update dual coding theory. So one possibility is that that theory just doesn't apply at all. So one competing hypothesis is called the distinctiveness theory. The idea there is that pictures are just more distinctive than words. Like, we only have 26 letters. You can't do as many combinations of letters as you can do combinations of pixels to make an image. Like, images are just richer and more distinct. And
It's
then,
a whole like a picture's worth 1,000 words kind of
exactly,
idea.
yeah. And that is the case regardless of whether you can visualize or not. You still have intact perception. So people still see that the picture is richer and more distinct than the words. So this could be evidence for that account. But if we still want to believe dual coding theory, some updates could be one, maybe it's that the multiple routes happen when you're first saving that information into memory, like when you're encoding it. Because it seems that people with aphantasia, they see things just fine. They save things into memory just fine. It's more just when they try to retrieve it, they don't use the visual route, right? So maybe it's just that by saving it with a visual and verbal route, it becomes a richer memory that you can access regardless of whether you visualize or not.
Because embedded in the image is semantic knowledge and all these things you can extract
Exactly.
from it.
Yeah. So maybe you're extracting a lot of information for pictures from the get go. But another possibility is that maybe if dual coding theory is right, maybe people with aphantasia are using a different secondary code. It doesn't necessarily have to be verbal and visual. maybe it might be spatial or motor. Like maybe there's many ways you can access that information. And we the difference in symbols versus pictures might be a little hint at that. So one thing is that our student who ran the whole study, Muhan Yan, she actually has aphantasia. She's at a 16 on the VVIQ, like full, like has no visual imagery at all. And so it was really fun running the study with her because we kept asking her insights or asking her predictions. And she was a pilot subject and showed exactly the results we found in our whole sample. And so we asked her, why do you think you did much better at the symbols? And she said she used motor imagery. She imagined herself drawing the stimuli. So she could imagine herself drawing the dollar sign, but she can't imagine herself drawing this complex picture of money, on a table.
Right, right, right. Interesting.
And so her thought was maybe she's using a motion based code to access that information. And so as a result, we've been really interested in this question of like what strategies are people with aphantasia using to do really great at like a lot of memory tasks, even
Yeah.
without
I mean, and,
visualization.
and I mean, it's a great example. And I'm sure there are folks with, without motor imagery who might have, another form, then use that other pathway to help in, the kind of encoding process.
I'm curious, what do you have intuitions on if there are certain strategies you use
It's a
to
good
remember things?
question because I don't have imagery in any of the senses, so I wouldn't
Mm,
be able to use that motor sense. But my instinct would be that I would still probably be better at the symbol, and it now just pure conjecture, why would that be? Maybe it's the fact that it's like more, it's like the most condensed form, kind of the
yeah,
idea. Maybe allows for more efficient storage or retrieval. I don't, I'm just kind of brainstorming, but I feel
that's
like
actually an interesting
I
idea.
feel like I would replicate that. Like I would probably remember the symbol better than the image, but I wouldn't use the motor pathway because that's not available to me. But I do know
Mm.
others in the community, probably many of you watching now, might have imagery in one of the other senses, auditory, olfactory. I don't know if money has a smell and he could
Oh, it
recall, but
definitely has to spell. I can spell it right now.
well, yeah. See, there you go. So depending kind of on your own cognitive profile, you might use what methods you have to encode, more efficiently. I think that just is intuitive to me.
Yeah, I agree. Yeah. Oh, that's really interesting to test. I mean, it could be possible that maybe since you might have used like more verbal strategies, maybe you are more able to encode more verbal information or use that dollar sign more efficiently than someone who's relied more on visual based strategies.
Yeah, that
Yeah.
would be my hypothesis. Because even with the images, like I'm thinking of if I were to look at an image of the dollar, it's not like I would remember the image necessarily. I would
Yeah.
extract the idea of dollars, from the
Yeah.
image, and like that's kind of what I would remember rather than necessarily the layout, unless maybe that was the specific task that was asked. The fact that this has kind of been 50 years of, I guess, the kind of ideas of how memory works. Aphantasia really shows, when it's like when something is different, it helps challenge and inspect some of the other kind of underlying assumptions. I think one of the things that
Totally.
has become very clear as I do, many of these interviews is often what's happened is the people doing the research often assume much of the world experiences the world like they do. And this goes right
Hmm.
back to, I mean, Aristotle famously wrote that, the mind does not think without images, which obviously is proven wrong, but it's probably because he thought with images. And so, it's one of the powerful things I think about the discovery of aphantasia. It helps, better inspect some of these underlying mechanisms or assumptions about how things like memory work.
Exactly. Yeah. So we're as a result of this study, we've been really interested in this question of alternate strategies. So sort of hinting at how you would perform at the task, like you would extract the verbal information. We're now testing out a sort of wacky experiment. We're like super early stages. We have not recruited people with aphantasia yet. We were like just seeing does it work with people in general. But do you know the New York Times game Connection?
Yeah, yeah, yeah.
Yeah. So we're curious if people's different visual imagery ability impacts how they do at connections. Because I guess for people who don't know, connections is this game. Yeah, it's this game where there's a grid of 16 words and they're actually grouped. There's four different groups of the words, and you have to guess what the groupings are. So maybe words might be grouped by rhymes with the same or rhymes with each other, but they could also be grouped by something that requires visual imagery, maybe like their shape, or they might be grouped by something semantic or knowledge, like it could be like names of, I think they previously had like words in titles of Quentin Tarantino films, or like words that also are homonyms with color names. There's like all these weird ways you can group the words. But we noticed that because of this, the groupings tend to often rely on different strategies. Like some require richer, more like verbal based thinking or being able to abstract away from the words, while some groupings are more visual. Like you need to imagine what the object looks like to realize that, oh, they all share this feature. And so we've made connections games that have more like visual groupings and more semantic groupings. And we're curious, do people solve the puzzles differently? Or maybe do people with aphantasia do better at the more abstract, like semantic grouping
For anyone
question?
watching along, we'll put a
Puzzles.
link to Wilma's
Oh,
lab and how they can
yeah.
participate in that game because that sounds fascinating and it'll be interesting to see if there's strengths or advantages maybe for some groups or others in the different types of strategies.
Yeah, because I think it's a really cool question of, yeah, do people with aphantasia have or do way better than certain types of tasks that use different types of strategies than people who have visualization or visual imagery?
Yeah, yeah. Yeah, that's interesting. I want to talk more about like how aphantasics actually encoding this information. Is it that they're extracting the semantics from the image, or that they're actually still storing the image and just not retrieving it?
Yeah, that's a really tricky question. So we've tried to study that. Maybe I can talk about a recent brain imaging study that we've
Yeah,
published.
sure.
So it doesn't give me the full answer, but this has been a question we've been curious about. So exactly, we've been curious about maybe people with aphantasia just quickly get the semantic information, like they abstract away from the image, like they're very efficient at understanding the image and they don't save that visual information. Yeah, or is it that the visual information is there, but they just access it in a different way? And so to test this question, we actually found a pair of identical twins where one has aphantasia and one doesn't, just by
Fascinating.
chance. Like, they knew someone in the lab, and they were like, "Oh, you study aphantasia. You wanna scan my brains our brains?" And what's cool there is that identical twins, you would think that in general, their, like, brain anatomy should be largely similar, not huge. There's been it's been hypothesized that aphantasia might have a genetic component, but here, this is a case where it cannot be fully genetically driven. And also they grew up in similar environments. So, anyways, we scanned their brains while they did a short-term visual memory task of, here's a basketball. Okay, delay. Now imagine that basketball in your mind's eye. Then we did a long-term memory task, where or visual imagery task where it's imagine what your childhood bedroom looks like. Imagine what your mother looks like. Like imagine these highly familiar people and places that both of them know. And what we found was that we did find traces of visual information during memory in the aphantasic twin for that short-term task, but we didn't find it for the long-term task.
Hmm.
And so it could be for the short-term task, maybe it could be that for the long-term task, it makes more sense to me that maybe their representation of their bedroom is then really more abstracted away. It doesn't have any of that like visual
Visual.
detail.
Yeah.
For the short-term task, we still didn't get as much visual information. But so maybe it might be something about the process of consolidation, like
Converting it from the
yeah,
image process to something semantic or that longer term
exactly.
storage. It's kind of like in working memory,
Yeah, exactly.
through the translation process. Super fascinating and a great coincidence or happenstance,
I
with
know.
identical twins, one with and one without. And it does. I mean, just in that in and of itself says so much about aphantasia that it's not purely genetic. And if they grew up in similar circumstances, is it even environment?
One thing that I so there is one difference between them that's very striking, and I don't know if it's related to aphantasia because, keep in mind this is sample size of just 2 people,
Yeah,
but
of course.
they are actually mirror identical twins. So they're a type of identical twin where they get flipped. So one is right-handed, one is left-handed.
Hmm.
And if one has like a birthmark here, the other will have a birthmark here. We also looked at like the almost handedness of their brain, and we also found that they were sort of flipped from each other. And so it could be something about like hemispheric differences in the brain could maybe relate to imagery in some way.
Wow. Wow.
Yeah. So the
Fascinating
one with
case.
aphantasia actually had usually language tends to be more on the left hemisphere of the brain, but the one with aphantasia had language on both hemispheres of the brain.
Hmm.
So
Very cool.
maybe that could like then promote her using more semantic strategies. I don't know. But again, take it with a grain of salt, only two people.
So, I mean, you've done several studies with the aphantasia community now, which maybe you can talk briefly about some of the other ones you've done. And, has this one been the most surprising? Which one has been maybe most surprising of the work that you've done?
I guess the twin one was actually maybe one of the most surprising because it didn't really like we thought either it'd show definitive like there is no information there during visual imagery because we told the aphantasic twin, imagine these basketballs and cupcakes and everything. And she says she doesn't see anything, but we can decode from her brain that there is still some information there. But at the same time, we don't find there's this argument of, or yeah, some people wonder if it's maybe like a lack of access to the memory
Right.
information, like it's that it's there, but they're just not able to access it.
Like kind of
Yeah, but we still find like the differences in the long-term memory task. We also in collaboration with my colleague Monica Rosenberg. So they've developed this cool method where you can take brain activity when people are resting or watching like an irrelevant movie and then see how does the brain naturally fluctuate during not doing anything. Like when you're just sort of like was it like mind wandering? And they've made them and then separately, they did a study where they asked people to report what were you thinking of in this moment? And they got all sorts of information on like, oh, I'm thinking about something related to images or thinking about something related to words. I'm thinking about something about me or something external. And then they were able to create basically an AI model that can then take that mind wandering activity and tell you what it's likely to resemble. Like this mind wandering activity looks like it's related to visualizing or verbalizing or external or internal things. And we took her model and then applied it to the twin data when we had them doing some mind wandering tasks in the scanner. And we found there that the aphantasic twin had no visual information during mind wandering. It was all verbal, while the twin with imagery had visual information during the mind wandering and not verbal.
so it could actually pick up
Yeah.
that difference. Wow.
So there were cases where we found clear brain-based evidence that there was no visual imagery happening. But at the same
Yeah.
time, in the short-term task, we get a little bit of information. So we didn't find like clear evidence for either camp, but I think that just makes it a very interesting mystery for us to keep diving into.
Yeah.
So we're actually scanning more people with aphantasia and without aphantasia. If anyone's in the Chicago area and wants to get in touch.
Again, a link will be in the description. What's great about these types of tests and experiments is it really goes to show is, this isn't just like a subjective, I think I can't visualize. I mean, there are, I'm sure, some people who fall into that camp, but in from a broader sense, a lot of the skepticism about aphantasia has been that it's highly subjective. It's, you fill out a survey and can we actually, do we actually know that this is a real difference? But if we can, we can measure, and there's been plenty of different types of studies on this now, but, just another piece of evidence to show that this is something that you can measure, in a brain based state.
Exactly. I feel like as a field, we're now in like aphantasia research 2.0. I feel like 1.0 was, hey, everyone, there's this thing called aphantasia, take the VVIQ. But it was really based on a lot of subjective measures and surveys. But I feel like aphantasia 2.0 is like, okay, now we have all these cool objective ways to look at aphantasia. Like Joel Pearson has developed a lot of cool methods looking at like physiological measures or his binocular rivalry task. But also, like, there's a lot of fMRI, like, brain-based stuff coming out. So now we see, like, yeah, aphantasia is a true experience. Now what does that tell us about how does the brain work? What causes aphantasia? But also how does memory work for as a whole?
Wilma, let's talk maybe about some of the other research that you've done. That's it. Maybe let's start with a recap of the drawing study. I think that's where we first met each other, and then anything else you'd like to discuss about the great work your lab's doing.
Thanks, yeah. So this drawing study, it was published in 2021, I think. And so basically We had developed in our lab, we were curious about what do memories actually look like in people in general, because in a lot of memory research, what researchers will do is show you a picture, like, okay, I show you a picture of a cupcake, and then after a delay, I ask you, did you see this cupcake or this cupcake? But in choosing the two cupcakes to show you, I sort of have to have assumptions about what details you'd remember or not remember. We wanted to know, what if we just let people freely produce what their memories look like? And so we realized drawing might be the best way. And so before studying aphantasia, we had done this experiment where we showed people rich scene photographs like bedrooms, living rooms, playgrounds, and then after delay, asked them to draw those scenes from memory. And what we were surprised to see, like, so many of our participants complained they didn't like drawing. It's a hard task. They did a fantastic job. So when I have you remember a list of words, you can only usually remember like maybe 7 words. But when we had people draw back these images from memory, they draw on average 150 objects. And they would, yeah, so they would draw the objects with quite a bit of detail and draw them in almost pixel precise locations, pixel precise sizes. And it's also let us look at interesting things like what false memories did they insert. So that was sort of the first study we had done. And then we were curious, are there groups of people who might show differences in how they draw their memories? And maybe we can use drawings to reveal these underlying like differences in what their memories look like.
Yeah.
And so I had found Zoe Pounder at this VSS conference who was studying aphantasics. And so we decided to see what happens when we have people with aphantasia draw images from memory. And what we found was that, well, first, there were no differences in drawing ability. Like people with aphantasia were just as good at drawing. But when they drew from memory, they lost a lot of the object detail, but they were totally fine with the spatial detail. So they would be able to accurately say, a bed is here, a desk is here, a lamp is here. And the spaces would be pixel precise. But they would tend to draw sort of a more like a schematic bed, or they might even draw like a circle and write the word bed in there. So we found that like people with aphantasia used less color, drew less details, spent less time drawing each object,
Hmm.
but used more words, but also were like very spatially accurate and had few false memories. So
Hmm.
we thought of this as like clear evidence of differences in memories between people with and without aphantasia. Also, it might be a potential objective measure because it's really showing this dissociation where they're fine at spatial imagery, but just don't have the visual detail.
And that the fact that these are two different types of memory being encoded, right? I know where in the room the bed was, I know where in the room the dresser was, but I maybe don't have that level of detail that would be encoded in an image. Back to that idea that an image is worth 1,000 words, so to
Yeah.
say. Do you think that translates in other areas of life? Like, does that mean worse memory if you have less details that you can draw? Like, what are the implications? What does that actually mean in
Yeah, I
in day
don't
to day life?
Yeah, it's interesting because I'm not sure if it necessarily means worse memory. It just means different memories. Sort of harkening back to what we were talking about earlier, then maybe people with aphantasia might then use these more like semantic or higher level abstracting strategies, which actually could be very helpful. Like, for example, when you're studying for an exam, you don't want to remember the exact figure that you saw in a textbook. You want to remember the meaning behind the figure,
Right.
right?
Yeah.
So it makes me think like, when in our lives do we even need to remember the very precise details? Maybe if it's like, oh, I need to buy this exact brand of like box of cereal that is my, I don't know, kid's
Police
favorite. But
sketch or something maybe.
oh yeah, that's true. Police sketch.
But
Yeah.
but but then that does raise the question of the false memories thing. So maybe you want to share a little bit about
Yeah.
that piece?
Yeah, so one thing is with the drawing task, false memories were pretty rare. So this is still qualitative. We don't have like super strong statistics backing it up, but qualitatively, people with aphantasia drew way fewer false memories than people with imagery. So people with imagery, they draw a living room and then make up things that weren't there that would make sense to be in a living room. Like, oh, there's probably a chair there, probably a TV there, even if there wasn't. So we were thinking, could it then be that whatever strategies people with aphantasia are using, maybe they're more effective? Like maybe they don't get contaminated by like visual images of other living rooms you've experienced.
Right, because because
Yeah.
because I guess how the difference between like a memory and imagining something, that doesn't actually exist, like these things can maybe more easily get blended together when you have imagery.
That's what I'm thinking, like, maybe people with imagery have so many, like, detailed visual images of living rooms that they all sort of, like, mix together.
Yeah, interesting. I mean, that has big implications. The
Yeah,
idea
because then
of
it's
false memories.
'cause then maybe it's like, visual imagery is, like, a problem and that it, like, contaminates your memory, I don't know.
Yeah, yeah.
Um,
You start imagining things, that didn't actually happen, or details of the memory that you kind of filled in the blanks because you didn't know what was actually there, and so the mind just kind of filled it in naturally.
yeah, exactly. Yeah, so we're actually running another study right now trying to measure false memories in people with and without aphantasia, or actually here we're looking at the whole range of the VVIQ.
Okay.
And in this task, we're basically trying to prompt people to use different strategies to remember things, like try to use like a very simple verbal strategy of just repeating that word over and over, or try to make a story of these words in your mind, or try to use a visual strategy, like imagine all of these objects together. And then basically, we're looking at, can we first induce false memories due to different strategies impact what types of false memories you have? And then how does that interact with your level of visual imagery? Like, yeah, do people with visual imagery have less false memories? And also, like, to what degree do the different strategies interact with your visual imagery ability?
Yeah. Yeah. I mean, that is really fascinating. Excited to see kind of the results of that because
Me too.
that's one of those ones that actually has real world implications, and might be some solace for the people who do feel like, and there is I would say a sizable portion of the Aphantasia community who, because memories are, I think we've talked a lot about memories and from like a factual standpoint, but there's also the emotional portion of like being able to re-experience a memory. It's easy to romanticize the idea of how nice it would be to relive your past experiences, or
Hmm.
whatever it might be. Things like this kind of help counter, show the other side of the coin. I think it's been a great conversation, though. I've learned a lot. I hope everyone who's watching along has learned a lot about Wilma's work. Wilma, where can viewers learn more about the work that you're doing in your lab and participate in any of the studies?
Yeah, so check out my lab at Brainbridge Lab at uchicago dot or sorry, brainbridgelab.uchicago.edu, or you can also email us at brainbridgelab@gmail.com. We're actually running, like, I think I described 4 different studies right now. And I don't know, there's gonna be a big aphantasia conference later, and we're hoping to collect lots of data before then. So
Before then,
please,
okay. So there's some there's please participate now. I will put all the links in the description below, for everyone who's watching to please participate. Wilma, thank you so much for a great discussion, and I look forward to seeing you again.
yeah, thanks so much for inviting me for this. Thanks everyone for your great
Thank you,
questions.
everybody.